This lesson will be on the second half of 10-2, multiplying radical expressions. In 10-1, we saw multiplying radical expressions such that 3 times radical 15. We'd factor 15, so we'd have 3 times 5. And because we have two 3's, we'd have the square root of 9, which is 3, and the 5 stays inside the radical. So our answer would be 3 radical 5. Remember that you can do this problem another way. By multiplying 3 times 15, you would have radical 45, and we could factor 45 into 9 and 5, take the square root of 9, and we would still get 3 radical 5. So you have two methods, or two ways to get to the same answer. In this section, we'll be using the distributive property to multiply radical expressions. This is problem number 7 in your book under Check Your Understanding. What we'll be doing is multiplying radical 2 times the sum of radical 8 plus 4 radical 3 by using the distributive property. So first, we'll be doing radical 2 times radical 8. When you do this, you can always simplify radical 8 first if you like. If not, we can multiply and then simplify afterwards. So radical 2 times radical 8 will give us radical 16. Then we'll use our distributive property to multiply radical 2 times 4 radical 3. This will give us 4 radical 6. We'll have to simplify radical 16. The square root of 16 is 4. Plus we have 4 radical 6, which cannot be simplified. So our answer is 4 plus 4 radical 6. In example 3 in your book, we'll be multiplying 4 radical 5 minus 2 radical 3 times 3 radical 6 minus radical 10. We'll as well be doing this by using the distributive property. So first we'll multiply 4 radical 5 times the 3 radical 6 and then the minus 1 radical 10. 4 radical 5 times 3 radical 6 is 12 radical 30. 4 radical 5 times a negative 1 radical 10 will give us a negative 4 radical 50. Now we'll multiply our second term of negative 2 radical 3 times 3 radical 6 and then times negative 1 radical 10. So negative 2 radical 3 times 3 radical 6 will give us a negative 6 radical 18. And negative 2 radical 3 times negative 1 radical 10 will give us a positive 2 radical 30. After doing that, we'll have to simplify each one of our terms. "30 breaks up into 5 and 6, neither of which is a perfect square root. So 12 radical 30 will stay as 12 radical 30. 50 can be factored into 25 and 2. We can take the square root of 25, put that on the outside with our negative 4 to give us a negative 20 radical 2. 18 can be factored into 9 and 2. We can take the square root of 9, put that on the outside with our negative 6 to give us a negative 18 radical 2. And 30 again breaks up into 6 and 5, but we can't take the square root of either of those, so we'll leave this as a positive 2 radical 30. Now that each term is simplified, we'll need to add our common terms. So 12 radical 30 plus 2 radical 30 is 14 radical 30. 20 radical 2, negative 20 radical 2, and a negative 18 radical 2 will give us a negative 38 radical 2. And this is our final answer. In example 3b, we'll be multiplying in a radical expression times a radical expression using the distributive property again. Remember that in example 3, we used a three-step process. We multiplied using the distributive property, then we simplified each term, and then we combined our like terms. As we multiply, remember that we're multiplying the outside numbers together, so 6 times 4 is 24, and we're multiplying the inside numbers together, so 7 times 10 is 70. Now 6 radical 10 times a negative 5, 6 times negative 5 is negative 30, radical 7 times 6 is 42. Now we'll multiply using the distributive property our 3 radical 2, so 3 times 4 is 12, 2 times 10 is 20, 3 times negative 5 is negative 15, radical 2 times radical 6 is radical 12. Now, that was step 1. Step 2 would be to simplify each term. 70 breaks up into, factors into 7 and 10. We can't take the square root of either of those two numbers. 10 only breaks up into 5 and 2. So this term will say 24 radical 70. 42 breaks up into 6 and 7. Again, we can't simplify, we can't take the square root of either of those two numbers, so this will stay negative 30 radical 42. The square root of 20 breaks up into 4 and 5. We can take the square root of 4, that's 2. So here we'll have 12 times 2, which is 24 radical 5. The square root of 12 breaks up into 4 times 3. We can take the square root of 4 as 2, and we'll have minus 30 radical 3. And then we'll look to see if we have like terms, which we do not. So our final answer is this expression. In example 3, we'll be multiplying radical expressions using the distributive property again. And remember that this is a three-step process. We'll be multiplying, then we'll be simplifying each term, and then we'll be combining our like terms. When we multiply 5 radical 5 times 6 radical 10, we'll be multiplying the outside numbers, so 5 times 6 is 30, and then the inside numbers, 5 times 10 is 50. 5 radical 5 times 2 radical 6, 5 times 2 is negative 10, 5 times 6 gives us radical 30. Now 4 times 6 gives us negative 24, radical 30. 4 times 2, negative 4 times negative 2 is a positive 8, radical 18. So that was step 1. Step 2 will be to simplify each term. 25 breaks up into, 50 breaks up into 25 and 2. The square root of 25 is 5. So we'll have 5 times 30, which is 150 radical 2. 30 breaks up into 5 and 6. We can't take the square root of either of these two numbers, nor do we have any perfect square roots as a factor. So this will stay as negative 10 radical 30. Same thing with 24 radical 30. Now radical 18 factors into 9 and 2. The square root of 9 is 3. So we'll have 8 times 3 radical 2. And now, that was step 2. We simplified each term. Step 3 will be to combine our like terms. So first, a negative 10 and a negative 24 is a negative 34 radical 30. 150 plus 24 radical 2 will be 174 radical 2. So our final answer is 174 radical 2 minus 34 radical 30.